Scalars and magnitudes of scalars. We have already discussed mathematically finding scalar multiples. Now we will sketch scalar multiples of vectors and understand them in context of word problems. So we will need to recall that a scalar is a constant number that is multiplied by a vector. So we might first have to find the vector, and then we can multiply it by a scalar. And then we find the magnitude the same way we have before. One type of scalar that we haven't quite talked about yet is the dot product. The dot product is kind of multiplying two vectors together. You could kind of see it as that. So what that's going to look like is if we have vector u, which we'll call u1, u2, and vector v, which we'll call v1, v2, then the dot product u dot v is going to equal u1 times v1 plus u2 times v2. So basically, instead of adding the corresponding parts, you're just going to be multiplying them together and then adding all of them. All right, so that is what we call the dot product. So let's do some examples here where we're just finding the dot product. So to find u dot v, we're going to take 6 times 2 plus 4 times negative 3. 6 times 2 is 12. 4 times negative 3 is negative 12. 12 minus 12 is 0. So u dot v is 0. And the next example here, we have u is negative 1, 3, and v is 7, 2. So u dot v is going to equal negative 1 times 7 plus 3 times 2. Negative 1 times 7 is negative 7, plus 3 times 2 is 6. So u dot v is going to equal a negative 1. All right, in these next examples, we want to find scalar multiplication. So we have already found the dot product, which is the first part. So find the dot product and then multiply it times the vector. So we know that u times v, or u dot v, is 0 from our previous work, times our vector u. So we have 0 times vector u, which is 6, 4. And then that just makes the 0 vector. So our vector is 0, 0. And the next one, again, we had already found u dot v to be negative 1. So we're going to take negative 1 times my v vector, which is 7, 2. So our new vector is negative 7, negative 2. Final answer. Now let's look at what magnitudes of vectors look like and how to find magnitudes of scalars and an easy way to do that. While at summer camp, you are enjoying a tug of war with your friends. You are on one side of the rope pulling with a force of 200 newtons. You decide to really go for the win and pull as hard as you possibly can. As it turns out, you are pulling with twice the force you were pulling before. So we want to represent this as a vector and understand what our new vector is going to be. So we're starting with we're pulling at a magnitude of 200 newtons in one direction. Okay, so then our resulting vector, our new vector, we are pulling twice as much, twice as hard, so you take 2 times 200. So you just multiply times your magnitude just like you would if it was the vectors. So that would be 400 newtons. So your answer is 400 newtons, and it would be pulling in the same direction as you just were, because that's the whole idea of what magnitudes do. All right, this next example, we're going to do the same thing. The speed of the wind before a hurricane arrived was 20 miles per hour from the north of west direction of 22 degrees. The wind speed quadrupled when the hurricane arrived. Draw and identify the scalar magnitude. Okay, so it's coming from north, east, south, west. It's coming from the north of west. So we're facing west and we're turning north. So it's coming from this direction up here. So the wind is blowing this direction. So my vector is going to start at my origin, and it is going to, and that would be right there, 22.5 degrees. So that means that we have this vector right here. And if we remember back to geometry, that makes this angle, vertical angles, are 22.5 degrees. All right, and so that would be down in the south of east direction is where it's actually going to be going. Now we want to find our magnitude. So we know that it's 20 miles per hour, but it's going to quadruple when the hurricane hits. So now our new vector is going to be going the same direction, and it's still going to be the same angle, 22.5 degrees, but instead of it being 20 miles per hour, it's going to be 20 times 4 because it's quadrupling, so that makes it 80 miles per hour. What our new graph would look like, you should draw it 4 times as long, but I kind of ran out of room, and it should be, you should also indicate the angle, just like we did here. So those are your notes over scalars and magnitudes of scalars. Go through some practice problems. Make sure that you actually get this. Understand how to draw them and what scalars actually are all about, and then you can take the quiz over the material.